Now, once we've done all the checks and if we never returned false, then outside the for loop, we get to say return true. This is the first version of the function. Are we done? Let's check. I'll read in everything. I press Ctrl E, and I'll try to run this thing. Okay, this is true. Okay, this is false. Now, at this point, we ought to start to be worrying a little bit because we haven't actually covered all the cases. Consider this kind of example. Let's say that the sequence is something like TTT. Let's not make it too complicated. And let's say that the subsequence is TC. Now, what would happen if I were to try to match the subsequence at the last character? If I try to match it here, this would match, but then there is no C here. Let's try it. Let's define it like that. And let's try to match it at the last character or the sequence. Let's check what the length of the sequence is. It is 7, so that means that we ought to try to match it at 6. Let me try to run this. Aha, we got an error. Why did we get an error? Well, intuitively, because we are trying to match the sequence like that, where this T and this T, they matched, but this C had nothing to match to, but we never considered this case so far. Let me go to where the error occurred. This is where the error occurred. I accomplished this by pressing postmortem debugging. Let me trace everything from the beginning though. So I'll put a breakpoint here. I'll say Ctrl E. And now I'll try to trace everything. So I go and I say step into. And now I'm here. So initially J is going to be 0. I plus J is going to be 6. The length of the sequence, if you remember, is 7. So that means that sequence I plus J is the last T. There is no sequence I plus J plus 1. So those happen to be equal because subsequence at J was T and sequence at I was 0. But now J is equal to 1. And this is going to give us trouble. If I try to compute this, I will get an error. Why would I get an error? Well, subsequence at J, that makes sense. That's the C, that's this C here. But subsequence at I plus J, so subsequence at I plus J, which would be subsequence at 7, that makes no sense because the length of the sequence itself is 7. So the last index in it is a 6. That is why if I press next here, I'll get a string index out of range. This is what string index out of range means. It means that I try to access a character in a string which doesn't exist. How do I make sure that my program never crashes this way? Well, I ought to make sure that I never have an I plus J which is greater than the length of the sequence. Now, one awkward possibility would be to just say, okay, if I'm here and I'm still checking, so I'm not yet sure that I ought to return true, but I plus J is already greater or equal to the length of the sequence, I just ought to return false. So I could say something like, if I plus J is greater or equal than the length of sequence, I ought to return false. Why does this make sense? Well, because in order to make sure that my subsequence matches the sequence at index I ought to make sure that all of those things are true. If I plus j is greater or equal than the length of the sequence, that means that in order to make sure that all of those are true, I ought to evaluate a comparison that's not valid, which means that there is no way for this comparison to actually be true. That means that I can return false straight away. Now, I could do this, but this is kind of awkward. Here's an alternative. I can look at the largest index in sequence, which is this, which I'd ever need to access. And I'll just make sure that it's still a valid index inside sequence. If it is, then all the rest are valid as well. Let me copy it over, and let me say, if this guy is not valid, what does it mean for it to be not valid? Well, it's not valid if it's greater or equal than the length of sequence. Because if it's equal to the length of sequence, it's not valid either. The greatest possible index inside sequence is the length of sequence minus 1. That's the last one. So if it's greater or equal, then I'll return false. So that means that I don't need to check this stuff anymore. Now, if I try to run my example again, everything is going to be fine, because now let me step into, now I'm here, and now I can try to evaluate this stuff. So the largest index that I'd ever need to access is 7. The length of the sequence, that's 7 as well, so this is greater or equal than the length of the sequence, which means that I need to return false. So I'll just return false straight away. Everything's good. Another thing that you might worry about is what happens when the subsequence is actually longer than the sequence. Then there's definitely no match. But as it happens, you don't need to check for it because this condition actually covers that. If the length of the subsequence is greater than the length of the sequence, then this will definitely be greater than the length of the sequence.